Hi, it's Jan Beta, and as you can see, and as it says here, this is a Sega Mega Drive 16-bit console that was donated to me by Anthony, who is a long-term patron of mine and did some very glorious donations in the past. This is part of it, and I thought it's about time that I inspected this a bit closer. It does work. It does partially work, at least. I got a cartridge and it has like a stuck down reset button, and it has some issues. I got one of these knockoff EverDrive things, and when I insert this, it just turns on briefly and then it turns off. So I think there's maybe there's something wrong with this cartridge, but maybe there's also something wrong with the power regulator stuff inside here. So what I want to do is to take a look inside and see if we can find anything, and then probably go and future-proof this for a bit. So first of all, obviously I have to open this thing up, and there's I think there's 6 screws on the bottom here. I don't know if this has ever been opened. No idea actually. So, and if I open this, I have to be careful because there's a wire or 2 wires coming from the LED there. So I have to unplug it on the LED side, I guess. Because the LED, the legs are just folded. This is a pretty cheap way of doing it. But that's how they did it. So there we are. Free! So we have to remove more screws here. Okay, so I'm going to keep these separately. They are different lengths. Yes, I should know. Ah, there's a tab. There's a tab that holds it down. On this side here. That will have to bend to the side, and then now we have our circuit board here. Okay, let's see. Here's our power switch. There's a lot of capacitors, a lot of small capacitors. I probably will have to replace at some point for future proofing. All Rubicon stuff isn't too bad actually. So yeah, definitely have to remove some of the dust on here. And there are like 2 7805 voltage regulators, I think, which should be replaced, I guess. And then a little RF modulator. This is our processor. This has a Motorola 68K processor. It has a bent leg actually. Ah, there's a little botch with a resistor. Look at that. This is the processor, and there's a little resistor, teeny tiny little resistor botched into there to probably pull up or something. I don't have a pin out handy, but yeah, dodgy bodgy. It doesn't look too bad. This is a little power board where the connector comes in. And one of the main problems with these is that there are like dry joints on that. But this one does look pretty good. I think I'll reflow those anyway. Interestingly, there's a Z80 on here, I think. There's a Zilog Z80 CPU on here too, to provide backwards compatibility with the Master System, which was a Z80 powered device. So there's a giant heatsink there for the voltage regulators. So it seems our reset switch is just mechanically stuck there. Should be, doesn't move a whole lot. We should be able to clean this. I'm just poking it through there. And then maybe it's going to work again. So I think that's the problem. There's a little dent there. So we could file that down a bit, and then it will probably work again, I guess. Let's see if I can find a nail file that I have somewhere. Yeah, somebody had a go at this and used like a screwdriver to get it out, I think. Which isn't always the best idea. I'm just filing this down a bit, so I think might be a good idea. And now it's completely loose, which isn't good. Which is a good sign, I guess. Yeah, that's more like it. So now the actual switch, which has like a rubber dome on top, provides the springiness for the switch. This is how it's supposed to be, basically. Okay. I'm going to use some compressed air on this, I guess, to blow out the dust. So let's check the regulators. They should, I think, both provide 5 volts. This is a 9 volt power supply, by the way. So there should be 9 volts here. Like from here to here. No? Yeah, that's 9 volts. That's 9 volts. Okay. So let's see. This should be grounded, I guess. Okay, there's our 5 volts from one regulator. There's our 5 volts from the other regulator, and the input should be the 9 volts, I guess. Or 8. 8.16. So here's what I'm going to do. I'm going to take my EverDrive fake cartridge, put it in there. It should make good contact and everything. And then measure the voltage on this pin here while I'm turning it on. So let's see. So I hope I don't short anything out. I'm just going to be extra careful. So, turning on. Turning on. Oh, and it immediately drops to 0. So, maybe there's something shorting out and some protection circuitry kicks in. Maybe it's just the little voltage regulators that can't take it. It might be that the protection circuitry in these sets in because the EverDrive thingy draws too much current. That might be a possibility. Usually they have like a protection circuit. The power supply is a new Meanwell power supply that supports like 3 amps or something. 2 amps, okay. That should be enough, I guess. I don't know. Let's find out. So I looked it up, and the original PSU provides 1.3 amps or something at around 10 volts. So 9 volts should be plenty to fire these things up. I'm just going to replace the voltage regulators because that's the main issue I can think of regarding what's happening here. So let's just remove the heat sink, I guess. I mean, you could replace these with like switching regulators and stuff like that, or kinds of fancy mods, because it will get pretty warm in here. But on the other hand, this is pretty much the only location on the board where it gets warm, or significantly warm. I guess the chips stay quite cool, actually. So there are screws from the bottom here. How do I get to those? Okay. Ah, there we go. There we go. There's a board. There's a nice RF shield on the bottom too. So, okay. Now we have everything we need to work on this. So, if you're familiar with my channel, you probably know the ZD915 desoldering station that I'm using all the time. I have the second gun on there, but it still works pretty well. So I'm taking these out. So putting in the other ones, the new ones. So I just coated them with some nice heatsink plaster, just like this stuff for transistors and things, not the high temperature stuff you use for CPUs. I coated my hand a bit in white stuff. I then screwed them down and now I'm about to solder them in. And these are 78S05, which are rated at like, I think 2 ampere per 7805. Yeah, let's try and see if it works. So first off, testing some voltages again, I guess. There should be 5 volts, 5.4, 5.7. Okay, so we are fine. These regulators work. Let's see if it breaks down with the EverDrive thing. Let's turn it on. Let's turn it on with the multimeter actually working. Okay, and it does the same thing, I guess. It's ultra uncool. So that's not our problem. It's the actual EverDrive. Okay, fast forward a couple of days later, and the console is absolutely fine. It was the multi-cartridge that I ordered that wasn't working correctly, so that I don't know. I opened it up briefly and looked inside, but it's all like surface mount, small pitch components, and I don't really have the nerve to go through every pin and check for shorts. I guess there's something internally shorted in some of the chips, or in one of the chips, or in one of the little transistors. I don't know. And it turned out it was pretty inexpensive to just order another EverDrive clone thing that I think that this was like 30 euros, and it comes with an SD card with all the games preloaded and stuff. So, and this thing works. So I'm pretty sure the console works, and we can go into further restorating it or conservating it. So the actual optical impression, apart from some dust, isn't all that bad. So it looks pretty nice. I still want to wash the parts in soapy water, so I can be sure that there's no germs left. I'm also going to. I bought a very cheap box full of these controllers of different kinds. Actually, there's all Sega controllers in there, and yeah. This one I already opened and cleaned off camera, and I'm going to do that for another one, to show you what these things look like from the inside and how to unbreak them. Mostly these are not really broken, but they have wonky contacts inside and stuff like that, so they are pretty easy to fix. So if you need controllers for these systems, it's most of the times, if you are a tinkerer anyway, which you probably are if you're using real hardware, old consoles, most of the times you can get these to work again pretty easily. Yeah, as for the console, there's a whole lot of capacitors in there. I'm not quite sure if I should replace them. Probably so, because this is a 90s console and the capacitors are pretty old, the electrolytic capacitors, and probably would be best to replace them all, but there's I don't know how many. There's a lot. You saw that when I had it open. It's all standard values, I believe, but I don't really know if I want to do that. Probably in a very, very short jump cut or something, so you don't have to endure me recapping old hardware again, because I'm basically doing it in every video, but yeah, that's what I do. So there was nothing wrong with this thing, and there isn't, except for the stuck reset button, which now works a treat. You can get these buttons, the one that's soldered to the board. You can buy these as spares as well. These break sometimes. In this case, it's just like a mechanical problem. It works fine. And the voltage regulators were fine, actually. Doesn't hurt to replace those, I guess, because they age as well. They're pretty sturdy, generally speaking, but they may fail. And if they fail, they basically put out the... they can fail in a way so that they put the input voltage out to the output, which would damage the ICs in here, because I think those are for providing the 5 volts supply voltages for the ICs, mostly. Yeah, there's definitely a lot of capacitors in there. Don't even know if I have enough in stock to replace them all. There we go. Ta-da! I think I want to recap this, so I'm just going to do that. Yeah. I would have to do it in the long run anyway, so I'm just going to do that. And then clean up the board really nicely in the process. And the case just goes into some soapy water. So, without further ado, let's go! Or should I say, let's go! Oh, that's another brand console, I guess. Ha! So there's a whole lot of capacitors under this heatsink here, so I have to take off my little voltage regulators again, I guess, so I can take off the heatsink. Well, I think I got them all. That's a lot of caps. Wow. So, yeah, I don't necessarily recommend this. Caps were fine, this was working fine, so just doing it for preventative maintenance rather. So, Okay, there we are. Let's see if it still works. Would be nice. But first let me reattach the heatsink here. Okay, let's try this. Yeah, and it still works. It does absolutely still work fine, it seems. Okay, let's leave this running for a couple of seconds to see if it really works. And I also want to see if any of the ICs get hot and if maybe I should put heat sinks on some of them. I don't know yet because I have no experience whatsoever with the Mega Drive, apart from playing it a couple of times at my friend's house. So, what I found out after playing a bunch of games just for testing, this gets pretty warm. I think it's a Sega custom chip of some kind. I'm probably going to put a little text in here in this video after I have looked this up. The Z80 processor, of course, these always get a bit warm, but not too much. 68K does get reasonably warm, but these are really sturdy, so I don't really need to heatsink that. Voltage regulators, of course, but they have a massive heatsink, so this should work with the new thermal paste and stuff. Okay, so it works. Let's see how the case turned out. Ta-da! Ta-da! It is a bit scratched, but there's not much I can do about that. But at least it's clean now. Also going to put some IPA on these here. Oh, and actually I decided to not put any heat sinks in, any extra heat sinks. There is a heat sink for the 7805 voltage regulators, and these are the parts that actually get warm. The ICs all stay within reasonable temperatures, so it's not that bad to leave them just as is. Just making sure the polarity of the LED is correct. Otherwise it wouldn't turn on, but it turns on. The longer leg is positive, so it connects to the red wire. You can barely see which one is the longer leg because they are so badly bent, but you can make it out, and the longer legs are the positives on most components, I believe. So there we are. Doesn't look too bad to me. Now I need a controller that's not squeaky. Let's open one up. I have like a bunch of controllers and I want to refurb one anyway to use, or two at least. So here's an original controller that's not a creaky one. There's actually different revisions of this. The creaky one, I think, is one that has the actual contacts for the cross here on the back side of the PCB and has like a mushroom-shaped thing that just pushes the buttons or the contacts from the bottom side actually. And these, I think these are newer ones, have the contacts on top of the PCB, as we're going to see. Just going to open this up and clean this to have one nice pad. And I have like a couple of these that I bought all as broken, but mostly they have just like dirty contacts and stuff. definitely a good idea cleaning these from time to time. Look at this screw. Yeah, well, doesn't that look nice? Yummy! Ah, okay, this has a lot of dirt in there. And this is the bottom side of the PCB. As you can see, pretty straightforward. There's contacts that are on the other side. And this is like, I think this is a multiplexer. Okay, so let's just get this out. There's a little, this is like pretty neat because the cable is secured in with these standoffs here on top. But that's pretty standard. They basically look the same as the Super Nintendo controllers. I'm just going to take this all out. And then we have our, these are like, this is rubbery rubber with carbon mixed in, or some sort of silicon stuff. It's not rubber at all, because you can't really mix stuff into rubber, I guess, without way too much effort. They wouldn't put that effort into something like this. These are pretty cheaply made usually, these 90s game controllers. So here's the front side, the top side of the PCB where the actual switches are, which are just, I think, gold-plated contacts on the top of the PCB, and yeah, they're just closed by the carbonized pads closing the contacts between these. Yeah, so this is like a switch that is closed by the carbon. So yeah, we're going to clean this up a bit. I'm going to clean the plastic parts, and I'm going to clean these carbon pads because they look pretty disgusting. Wow. This is yuck. Okay, I'm just going to put this into some soapy water and be right back. For the PCB, I'm just going to use isopropyl alcohol and clean these spots there. And I think I'm going to finish with the light coat of contact cleaner. But this is probably what prevented this from working correctly. Just the dirt on the contacts here. I apply a thin coat of contact cleaner to the contacts. This is something that this is lubricating as well and stuff. Highly recommend this, by the way. Much better already. Nice. Yeah, these are pretty clean now. Ta-da! So the whole thing cleaned up pretty nicely with some soapy water and a bit of work with the toothbrush. And just lost one screw. It has some scratches and stuff, but that's just... I mean, it's an old game controller, so what do you expect? So, but it doesn't look too bad. And I really like these controllers, the form factor and stuff. It just feels right to me in some weird way, I don't know, even though they are pretty cheaply made. So there is a little part that broke off from this joypad thing. I might want to glue it back on, I don't know. Don't think it makes much of a difference, but it should go here. There's also other parts, little parts. I think I'm just going to glue it back on and try that. So I got this stuff here recently, which is basically, it is like a model making plastic glue that is basically mostly acetone, I believe. So it should really bond the plastic together, like it's like a plastic weld. It becomes one piece of plastic because it dissolves the plastic chemically, and then it becomes one piece again. So this is probably the strongest glue you can get for plastics, because it basically makes the plastic one piece again. So I'm going to apply this, and I think I have to put like a little strip of tape here to hold it in place on this flat side here. I think that's what I'm going to do. This comes with a nice needle thing to apply it. So there we go. It's just completely liquid stuff. It's pretty easy to apply. So I'm going to put this on a piece of tape here, so we can hopefully just exactly how it belongs. Yeah, doesn't look too bad. Oh, I think I'm just going to let this sit for a while. Just gonna leave it like that for a bit. So I left this to dry for quite a while. Should be done. Yeah, it is. Okay, nice. That seems to have worked pretty well. There's still a gap. There's a little piece of plastic that I didn't find that goes in there that probably fell out at some point during the life of this controller. Hope it's gonna work this way too. There's these little things that prevent it from popping out of the case, I guess. We'll see. But it should work fine. I guess it was in there before. This should go in here. Yeah, it supposedly works fine. So with these, I'm just going to put a little dab of contact cleaner on them with a cotton swab. You have to use something that doesn't dissolve the silicone stuff for this, obviously. Look, and you wipe off the... I hope this is going to work, because you wipe off the carbonized stuff there, pretty much. Okay, let's just try if this still works then, after a while. So the buttons work, the cross thing doesn't work at all, so I guess we have put the plate back in backwards some way. So let's open it up again and pretend it never happened. Yeah, that was that was very, very, very stupid, because the contacts are of course on the PCB, and I put this thing in the wrong way, so the contacts were not facing the PCB at all, which of course doesn't work at all, and it feels weird too. So okay, as I said, let's just pretend this didn't happen. So this is completely and utterly working. I'm going to check out more Mega Drive games on my Twitch channel for sure. That is linked in the description actually. And I don't know a lot of games, so if you have any suggestions for games to play... Okay, I can jump with B. This is a good game to try out all the joypad functions actually. B is jump, A is like use the... whatever it is. Like a sling. Okay, and I don't have any stones left, okay. So if you want to see me failing at games, as I always do, basically, check out my Twitch. And I hope to see you again on this channel sometime. Hope this was fun and informative for you, even though I didn't have to do a lot of repair other than the reset button. But we replaced the voltage regulators, we replaced all the capacitors in this thing, and it seems to be running flawlessly. And also, I repaired one of these, which is nice, so I can actually play games. Yeah, hope you liked this. Hope you stay tuned for more. I'm Jan Beta. Thanks for watching. See you next time. Bye. I kind of wonder if I should retrobrite this.